talk at 2 o'clock after lunch. So I will try to make this a bit invigorating. We have 30 minutes to talk through some exciting things that I'm quite passionate about. So I hope I'll be able to transfer some of my energy and enthusiasm to it. So the title of this talk is Big Data, Data Science, and Real-World Data in Health. Where does one begin? So we're going to spend some time over the next 30 minutes talking about this intersection of data science and healthcare, and where I think you are well positioned to make a contribution. So as a quick introduction to myself, I am an associate director at RSM UK Consulting LLP. RSM is the #6 global consulting firm, audit tax consulting firm. I am the head of the Data Intelligence, Analytics and Insight Unit, and my group is really focused on looking at the key problems incumbent in data and architecture within organizations. In addition to that, I have a second life, an academic life, where I focused on research looking at digital innovation in healthcare. And as such, really today, it's kind of an intersection of both things coming together, the practitioner and theory coming in one place. So I find when talking about subjects, it's always very helpful to think of an illustration or a concept. And one of my most favorite things to do in lectures that I'm giving at university is to start with a motif from a movie. And usually from a movie, now that I realize I'm getting a bit older, usually from a movie that the students don't necessarily know. But I feel pretty confident in this audience. I feel pretty good in this audience that you all might recognize this film. And so this is Marty McFly from Back to the Future. And in this movie, as you know, the basic premise is young Marty McFly is friends with a scientist who's discovered a mechanism to accomplish time travel. And as one does, the scientist at the beginning he believes is killed, and he escapes to go back in time to basically, he basically goes back in time because he's trying to escape some terrorists attacking him. And then while he's back in time, he's trying to figure out how he can get back to his current time frame. And so when I was thinking about this talk for this afternoon, there was one scene from this movie that I felt would be a very, very useful device to think about this challenge of data, architecture, and healthcare in view today. And it was a scene from the film. If you recall, this was basically the time-traveling device, and it was next to this device called the flux capacitor. And within this showed the destination time where one wanted to go to, the present time, and in this instance he was back in the 50s, and the last place where he was, which is just quite close to the current time right now. So I thought this was quite useful. But in thinking in this tripatriate process of time, this is actually something that's been quite useful in talking a bit about data, architecture, and healthcare for this afternoon. So if you bear with me, let's go back a little bit farther in time, for about 20, 25 years ago. When we thought of the conventional hospital clinical patient record, back in the 80s, the way in which these data records were stored were within filing cabinets just like this. And effectively, each one of these files would have been your particular patient record, would have your entire clinical history, all the notes that a doctor may have reported about your condition, your prognosis, medications, all the information is stored and filed in this sort of capacity. There's no digitization, and the real computing element of these records really came back down to the clinician. To have the memory to know, all right, this is the particular case history, and when you come into the hospital or you come into a primary care facility, you would basically quickly refer to that information, know your history, and assess and analyze that information. Now, a key issue with this type of data storage, it doesn't really lend itself to any sort of extensibility, because the key component and the critical path failure and all that is the clinician. So remove the clinician from that environment. There's very little capacity for others to know that information. In addition, when you move from one area to another, that physically requires the files to come with you. Often files will get lost, information will be lost. Not a very sophisticated setup that we have. But before power computing, the digital capacity that we have today, there was really no other choice other than to have a data record stored in this fashion. Now, when I started my career in and around the late 90s, one of the things that I really was thinking about when I started my career was basically debating whether to become a history teacher or to go into computing. And it was a weird dichotomy. The reason why I went into computing is that, if you recall, from the late 90s, the internet was quite an exciting era. It was the dot-com era. People that had any sort of crazy idea could start a company. So any sort of concept or idea that you could think of could somehow be instantiated in some sort of internet technology. So I was like, this is the place that I want to be. And in my very first job that I had in computing, so having studied computing at university and having my very first computing job in the 2000s, I remember something from my very first boss who worked at this healthcare firm that I was working at the time. He said something to me which is still applicable today. And he told me that medicine is one of the most data-intensive, yet least automated of industries. So even though, if we flip back to this core composition, even though when we think about it from a data perspective, there's so much information there. In the 80s, at the time this picture was taken, the amount of automation that was occurring with information was quite limited, and even to the 2000s, the way in which that data was integrated and the interoperability of that information was also quite limited. And there's some key reasons for that that we'll explore in due course. So we've started from the past, from the 80s, and thinking even before, in the filing cabinet of core data records. We've gone forward to the 2000s and starting to use digital technology to try to harness and grapple and deal with this information, at least digitize it such that it can be accessible. Now let's go forward into the 2000s and see some practical implications of where we sit with these core issues of data aggregation and data assimilation within clinical medicine. So in the 2000s, one of the key issues that we've had from a clinical healthcare perspective is most people don't like going to their GP. Now, you could debate reasons why that's the case. Like, one reason could be they just can't see their GP, like one.
About the UK,
Yes, yes. But this is not just applicable in the UK, this is also an issue in America as well. Yeah, yes, it's also a big issue in the sense that for primary care, it comes back to that central hub and spoke model. The GP being the center of everything that's going on. If you have an acute situation, let's say your children are ill, you don't want to wait to see someone, you want to see someone immediately. So what happens? In all sorts of, in systems theory, the same lowest common denominator effect takes place here in medicine. People go where they can get immediate care. Where is that? Not the GP, it's the ER, it's the A&E. But the problem with that, with so much activity occurring at the A&E level, it becomes quite expensive. Because A&Es, or ERs in the States, A&Es here in the UK, they're not designed for this type of setup. They're designed for emergency reactive situations. They're not designed to see someone if their child has a temperature. They're not designed to see you if you're not feeling quite well. But the reality is, when you look at the system, because of the frustrations of the overall system in getting access to care, this is where central activity is taking place. So recognizing this in the UK, a core policy initiative since the middle part of the 10s of the 2000s, I don't know what you call it these days, has been to move from what's called 2 degrees of care to 1 degree of care. And the cost modality from one to the other is one's expensive, one's less expensive. Why? Because if you have a clinician, a GP, diagnosing you and telling you what's going on, that can be a lot more effective because you have personalized response, that personalized history with access to information, than you do going into an A&E where someone doesn't know you. So quite a simple concept, But when you think about it in the context of the UK National Health Service in its entirety, it's quite a big problem that we're still grappling with. Not enough people are using the core capacity. Yes?
Just be devil's advocate. Sometimes the GP gets it wrong, so you end up there anyway. So that's been my experience.
What do you mean by that?
They misdiagnose, and the problem gets worse and worse until you end up. I have that personal experience of it, so quite the other way around. So that's another problem.
Yeah, that is another problem. So in fact, so that's even talking about another issue. So on one hand, the policymaker can say, wouldn't it be great if everybody went to their GP? But on the other hand, if you overburden GPs and they're again hard to reach, people are going to go the other way. So this is the dynamics that are going on here. And for technologists and for informaticians, which I imagine all of you are, some capacity, there's some intrinsic issues to think about here from a data perspective. So here we've talked a little bit about the context. Now let's start talking about the opportunities and what exists. So what's happening with data and information is there are some real clear changes in public mindset to data. When you think about the way in which you interact with technology nowadays, we have a lot of power accessible to us in these little devices. I can't imagine going half a day without my smartphone, even though the battery only tends to last for about 2 to 3 hours if I charge it. But nonetheless, without having the capability of having this device, it's hard for me to get around to think about going about my day. And as the average members of the public, we all have these same sort of expectations from these devices, and as a knock-on effect, have the same expectations from all types of services that we receive, whether it's from banking, whether it's from our expectations from IT and the places that we work, and finally, and the subject that we are on today, our expectations from healthcare. So people expect to have, at their fingertips, accessibility to information, the ability to access that information, to know what's going on, and to have that relevant to themselves. So it's creating a whole dynamic and change in mindset for where people are looking at information and the things they expect from the services that they receive. In addition to that, from a technological perspective, there's more and more proliferation of devices that are collecting data. So some of you might have wearable devices that track how many steps you take per day, how well you sleep, what your average heart rate is. So there's all sorts of devices that are being developed now that are being used in a casual context, maybe to provide you a nudge to get up and not sit all afternoon in some talks, or to get up out of your seat to get a glass of water, so you're not sitting at your desk all day. Nonetheless, all these things are creating more and more data points that have relevance in a clinical context, because if you start connecting the dots, these things have applicability to health. The problem, though, is although these things are here and present, the way in which they're structured from an information standpoint is rather undisciplined and rather disconnected. So despite the ability to connect this information, the way it can be used in a clinical capacity is still quite limited. So several studies have been done now looking at what is the actual impact of wearing a Fitbit over time. What's the actual impact on someone's health and their weight over a period of years using these devices? And the research tends to show not much. And I would argue to say the reason why that's the case is because we have not yet figured out how we take this diverse and ever-increasing data landscape and integrate it with the clinical health network and clinical health capacity to allow our clinicians to impact the way in which we are living our lives. Now, on top of that, in addition to the opportunities that are arising with more and more data devices, we're also seeing rapid advancements in the way in which we're treating data management capacities. I caught a bit of the previous talk, and what's quite interesting about that was if you take conventional software engineering, it's evolved in the context of thinking about the cloud and considerations of the cloud. But even with the cloud and whatever's coming next, beyond the cloud, the core capabilities and the core requirements that you need from a technology standpoint are there. You need to store information. What's great about that is storage of information now has become quite trivial. It's pretty cheap. to store data as opposed to where it was 15 years ago. The ability now from a computational perspective to take massive bits of information and analyze it and parse it in a constructed, repeatable way to develop patterns by using programming techniques and machine learning and other methods drawn from artificial intelligence. This isn't Star Trek. This is really going on right now. But again, the challenge is, even with all of these advancements that have been made in as far as computational technology is concerned, we still exist in this very fragmented data picture that makes it difficult to connect the dots and to make things interesting. But where there are these problems, there is opportunity, and that's really what I arrived to at the end. There is now a real opportunity for more and more informaticians and architects like yourself to really start saying, you know what, it doesn't need to be like this. We can provide systemization and structure to the way in which these data sets and the way in which this information is organized to allow us to draw the benefits of general information data management that we see in all other industries. But healthcare is really lagging behind from. Now, on one hand, that sounds quite idealistic. Yes, okay, that may be possible. We, though, still have an opportunity. We still have a challenge in that there is just a lot of noise about what is it exactly do you do. So, on the right here, I have this word crowd of all these different words and terms having to do with big data. On the left, navigate here, so just some technologies having to do with using big data from the internet capacity. The key thing that I really want you to take away from this talk, and you take away anything from it, is all this doesn't really matter. The underlying, whatever the new technology is for today, and the new one that will be tomorrow, and one the day after that, the fundamental principles and mechanics do not change. And what is underlying need here that's required in healthcare is a core systemization, integration, and architecture for the way in which we treat clinical data, for the way in which we receive inbound personal data that's impacting the clinical ecosystem, and really constructing a core interoperable way of considering data and information. And if we're able to achieve that, if we're able to promote the use of standards and the use of data sharing in this sort of context, we can go a long ways to realizing a new vision for the way in which healthcare can really be impacted in a personalized way. This next slide, which is very, very hard to read, I think, from the back, really conveys many different data sources that exist in healthcare, both on a structured capacity and an unstructured capacity. In a structured capacity, all we mean by that is these things either exist in relational databases, in very reliable form, in very structured form, in a way that's repeatable and accessible. An unstructured capacity may exist on minutes, may exist on Word documents, things that are not tabularized and accessible in a way that's repeatable, but nonetheless are data sources in themselves. Again, what I want to draw your imagination to in this context, in this frame, is the beginning of the capability of looking at this and saying, how from a systemized perspective, how from the point of view of as architects, can we take this information and look at either creating new frameworks that we can apply on top of this to allow for systemization and interoperability, or how can we look at this in the sense that we weren't going to apply that and using different methods and using different models that may exist in hospital A and hospital B to allow an end goal of data exchange for information. So think about that for a moment, and we come back to the question that we started with at the beginning of the day, where does one begin? And for me, one of the reasons why I was quite excited to come to this talk today, when I think about this problem of data science, the large amount of data sources, what the solution to making all this change and really pushing a new world, a new vision of clinical applications within medicine comes back to architecture and principles that you are all quite familiar with, and in the sense of structuring them in two basic areas. One, what are the core operational processes, business processes, you can call them, I prefer to call them operational processes in the clinical context, but what are the core operational processes? How can we systemize them? How can we identify what they are? And Are they happening in a basis that are repeatable? They are. So identify them, structure them, create design patterns around them. And the second comes down to old-fashioned IT infrastructure. So everything begins with the electronic patient record. On top of that, we start to see consumer devices that are introduced into the mix. On top of that, the reporting and the aggregation of all those sorts of data sets and information to provide perhaps patient information or patient accessible data to provide real-time feedback on what's happening within your life. And then on a more advanced standpoint, from a clinical perspective, to allow clinicians the capability to take that information and say, you know what, something's happening here with this patient. You know, I need to tell them that, you know, I can see what they're eating. You know, there needs to be an intervention in the way they're consuming. And I can use that interact from a real-time capacity, so we don't have this classic standpoint where medicine is reactive. So the key point here is what I think is going to change this dynamic, where we have an industry like medicine, which is quite slow when it comes to technological change. It takes about 17 years from the time something is discovered to the time that it's implemented clinically. That costs a lot of money. One of the key ways, among many, but a paramount way in which we're going to change that and tackle that is by professionals such as yourself getting involved in applying core architectural principles to the way in which data is shared and integrated within a health platform. It's desperately needed. It right now does not exist. Every time that I get involved with a clinical research project that involves software engineering, effectively what happens is the researcher starts from scratch, builds some sort of system, develops it, deploys it, and when that's over, no one ever uses that code again. There's no sort of thought to taking that information, taking that data, sharing that with someone else. Very, very rarely does that happen. And effectively what we have happening over and over again are non-specialists leading software engineering projects that are ultimately poorly designed. And if they were in other industries, they just wouldn't be developed like that. But this can happen because of the way in which medicine is structured and regulated and really controlled by the clinician. Now, by no means am I saying that somehow as software engineers or architects or computer programmers or business analysts are you somehow going to usurp the authority and context that a clinician has. But what I can say, though, is that voice, that perspective, that architectural footprint that is present in looking at and deconstructing problems from an architectural standpoint are critical and fundamental in medicine and require much more energy and enthusiasm in their delivery and execution. So what I would like to leave you with this afternoon are some things. And so this is my call to arms for all of you. Please, if you're not, consider getting involved in medicine and consider getting involved in the world of information management in clinical medicine, because your skills of architecture and your perspectives on architecture are quite needed and will be incumbent to creating a new data infrastructure that needs to be developed, which is still in very nascent days. Some ways you can get involved is get involved in BCSL to start, if you're not. And after this talk, feel free to send me an email and absolutely talk to you about projects and initiatives that are going on for you to learn more what's going on in this place. Now, if you get involved, again, everything comes back down to thinking and considering things from this core architectural standpoint in view of medical informatics, and realize that in order to achieve this future vision of a more integrated and connected digital infrastructure, which we are on the cusp of, a lot of work needs to be done. But the work that needs to be done is foundational, comes down to the skills that you already have. It's just applying them and making them integrated within this context of this ecosystem, which is conservative, but can be structured through the use of good principles and software engineering standards. So that's it. Any questions or comments?
One of the big things is with certification is revenue, because the patient has been so confidence and so on that. And you go about almost that's
Yes, no, that's a really, really good point. So I think in as far as information governance and patient privacy, there are two big considerations to think about. The first is, as a patient, I don't want my information or clinical history being sold and being used as an asset. And I think most people will feel that way, on one hand. So that is about good controls, good information governance. But on the other hand, from a research perspective, one of the big opportunities with big data is if we could aggregate all the data in this room regarding all of our clinical history, and then aggregate that against all the people that live in London, and then aggregate it against that of all the people that live in the UK, all of a sudden we have the opportunity to take significantly large sample sizes of information to create insight into what's happening. Sometimes we will, sometimes we won't, but we have that opportunity that we've never had before, that we most certainly cannot achieve when the information is residing in this. So with that, there's a tension. There's a tension of privacy, and there's a tension of data access. So how can we solve that? I again go back to the theme of this last 25 minutes. It comes down to good architecture. And so we need to create a security construct that ensures that if we send data out, that we know where it goes, that we strip out patient identifiable information. And I think most people would be reasonable to the standpoint that if you were to remove the identifiable information that knows that this is Edward Meinert, this is a 38-year-old American, if you were to strip out that information or anonymize that in some way, but allow the rest of the data to be used for the good of science, most people would probably be okay with that. But to address that, I think, comes back down to architecture. It comes down to thinking about these considerations and views, working with stakeholders to understand what the considerations are. And as we go through this journey, thinking of the right way of architecting this to ensure that we get the right solutions.
Thank you, Ed. And 20 at 38, I don't think so. Any questions for Ed? Please feel free to put on Slido. Ed's actually jumping on a plane soon, so thank you.